Angular quantities. In this three-part series, I will define the three angular quantities of rotational kinematics. The first quantity is called angular displacement. It is the displacement of this object in terms of the angle that sweeps as the object rotates around the center of this circle. By definition, that angle, theta, it's Greek letter theta, essentially it's a letter O with a horizontal line drawn through it. As that object undergoes that angular change, it sweeps a distance L at a position of R away from the center. So we define theta as a ratio between those two quantities, L divided by R. Now, since these are both linear measurements, what will happen is the units will cancel each other out, and that means that theta does not have any dimensions itself. It's just a ratio between these two lengths. Now, we further define that by saying that if L is equal to R, so that particular case, theta is going to be called 1 radian. That's about 57 degrees. And that's how we define a radian. A radian is, or 1 radian is the angle the angle formed when L is equal to R. Now, we can further explore this and compare radians to the circle, measure it in degrees perhaps. Since we know that the circumference of a circle is equal to 2 pi times the radius of the circle, we can take that and insert that into this equation. So theta is going to be equal to 1 revolution of L, so 1 complete L around, divided by R, so 2 pi R divided by R, the R's cancel out, and that says that theta is equal to 2 pi radians for 1 complete circle. Now we can also call a complete circle a revolution, and 1 revolution is 360 degrees. And we've already said that that's equal to 2 pi radians. So you can use this to convert from revolutions to degrees to radians. Now, when you convert to radians, don't forget to actually plug in the value of pi, 3.14. You can't express any of these calculations in terms of pi. You have to actually use the value of pi to arrive at the final answer. Now, one thing I just want to point out, that although the angle may be the same, the further you get away from the center of the circle, the greater the L is. So let's say that we have a theta of 1 radian. So the object traveled 1 radian. Well, if it's traveling at this distance, it would have this particular value of L. But let's say that it's closer to the circle. You can see that the value of L will be much smaller.